Now, welcome to part 2 of the Wadkin breakdown and reassembly of the machine, put it back in action. What I've got here is the part that broke down. The tread went completely in this guy over the years through lack of lubrication. It was caused by a grease nipple. The grease nipple is up here, and the grease channel to go down into to lubricate the bar, that had got blocked, so therefore the old one, the old fitting, wasn't getting the lubrication it required to carry it up and down the bar. Over time, dust got into it then and the breakdown process occurred. So it takes a long time for it to break down. The sign on the machine that it's not working properly is that the rise and fall mechanism starts to get tight. And when it's tight or hard to move, there's something wrong down here somewhere. So you can see there, even on this video, I make sure that everything's cleared out again and that grease is coming through the actual grease nipples. So that's the bar assembly. There's a bearing at the back. That's the back end of the machine. There's a lock and nut bearing here. That'll be out through the actual frame. It'll go out through the frame at the back of the machine, and then we can lock it. The front end of it is like so. Here we have a bearing to go on first. We have a little a keyway which goes in here, this slot here, and then we have the actual helical spiral threaded rise and fall mechanism. So that goes on there. The keyway stops it from twisting, obviously, or from slipping. You'll notice a little channel here with a spiral type of groove in it. That little guy there. That's to, when the grease nipple in here is greased, the grease comes down this channel to lubricate this and the bearing. So that's the purpose of that guy there. So that's the arrangement to go back in. Now I've already got this one there. I've got the old mechanism on it there. The other fitting at the far side was fine. So I've threaded that in. I'm ready now to put on the bearing. Now when the bearings are out, I must state, when I took out the bearings, I made sure that the bearing itself was cleaned down. So I normally clean them down with a little wire brush and diesel, and make sure that the bearing, there's no wear on the bearing. You'll know if there's an awful lot of, you'll feel it, you go by feel. So I couldn't find any wear on the bearings whatsoever. There was dirt and grit in them, alright, bit of dirt in them, but from the grease over the years, but nothing much. So all the bearings seem to be okay, so I'm going to opt to stay with them. If they are worn or there's play in them, we'll then replace them. It's well worth the cost. So this guy goes on here, bearing goes on there, my keyway goes into position here, and then I put on my helical threaded rise mechanism, that goes on so, and then we have a lock and nut here. Now everything is thoroughly cleaned before I put it back into position there. There's no dirt, grit or anything there. I've washed everything down and cleaned it. So I'm going to send that bar back there now, through the back end. And I just wind that gently there, and there we are in position. So that goes in sweet as a nut there. I'll go to the back end now and I'll put the lock and nut that I have here. This lock and nut, I'll put that at the back. So this is the one in position right now. Just go to the back and tighten that up. Now the bearing is in position here. It can't be seen on camera obviously, but we'll just lock it up again now. We're just going to tighten it all up again. It's a left-handed thread on this, so we tighten that fella just enough for the moment. We don't over tighten anything for the moment, so just enough to get the actual bar rotating. So I don't want to tighten that back there too much because I don't want to put wicked pressure on the bearing itself. That needs free movement, so it's just the bare amount, and then we lock the back nut has got 2 grub screws in it like so. So them grub screws, when we have that tightened left-handed, when we have it tightened to its maximum, I think it's 10.5 mil from the outside to the end of the bar. That's the setting. I measured it before I took it off, and we lodged the grub screws back into position to lock that. So that will give the required pressure onto the bearing at the front. We don't want to over tighten because that'll only wear the bearing away. So I always have to be careful with bearing work. So that's the arrangement. This bar, when it comes down, you'll see that there's a channel on it. If I look in here, you'll be able to see it on this one here. Sorry, there's a cylinder on it. When I say channel, there's a cylinder on it there. And that cylinder when I invert this, if I pull it over here, you can see it on camera there, I hope, that there's a hole here. So when I flip that over, I'll log it in there onto the cylinder on the bar there, and that's what holds the whole mechanism to carry the triangular piece, this piece, up, down on both sides. So calibrating it later on then, in order to calibrate it, to make sure that this arm and this arm are level, and that it's calibrating with the blade above and the head, because you can't alter the mechanism above here. The head is fixed, the blades are fixed in at a certain, the cutters are fixed in at a certain point, because I have there's a tool for that on the machine. So in order to alter the carrier pieces to get the table level, perfectly level and parallel to the cutter block, I can independently rise those by opening off the nuts here and twisting left or right, whatever the case may be. We wait till the machine is back together again and put all the parts together again and do left and right. That's all I've got to do. Put in these guys, put back on the bolts, hold it together. I've already dealt with the table there. I might show a little clip of just the rollers, how I get them all parallel to make sure they're actually true for the wood going over them. So that's table rollers. So I'll put this guy on, I'll put on the next guy. I will then push the table back in, and I put the nuts for carrying the table and holding the table in position, put them back in. I'll run timber through it then. We'll come back at that stage and we'll look at it again to show how we true up left and right, to calibrate it, to make sure that when the timber is going through, that it's not wedge shaped like so, that we don't get a narrower point here and wider here. So we get it accurate to 0.1 of a millimeter. That's the calibration I'd always try to achieve, and it's perfectly, it's quite doable. It's very doable on these old machines. Wadkin were a fantastic company. The engineering quality was absolutely superb, and they always thought of the guy coming after them. If a repair had to be effected, they always made it fairly straightforward to do that. So that's why I love these machines so much. So we have a simple repair there. This is just a brand new piece. We have a machine that we can actually cut multiples of them again, just in case it failed. But we do get a special cutter to cut the actual thread in it, because there's an Acme thread to gauge the pitch and so on, the depth. Anyway, we did that and we have it done. So I hope that is useful in showing when a machine like a Wadkin gives a bit of trouble, that how we can strip them down, find the fault, find the cause of the fault, get a part made or buy it off a Wadkin or Dalton's in England, and then re-put the machine back together again, and finally calibrate it so that we've got absolute accuracy. Because when you're doing fine cabinet making work, joinery or whatever the case may be, especially fine furniture, this is the workhorse and you need it. The machine is only as good as you're capable of setting it. So sharp blades, mechanisms that work all the time. There's other parts of this that have to be looked at as well. The drive mechanism, has to be oiled every so often. So the maintenance is very important. Lots of people don't do maintenance until such a time as the machine breaks down. In my case here, I didn't own this machine only up to a few years ago, and I knew there was a fault with the rise and fall on it, but it's only when the part fails that you actually go and search for it. So it's better, prevention is better than cure. So the grease nipples would have been the cause, block grease nipples, channels, were the cause of the part breaking down. But to get 50 odd years out of a machine or more without a breakdown like that, that is hugely significant. There's no machines in today's world that will last the test of time like these guys. The quality of the precision engineering in them is just absolutely superb. That's what I love about them. They're a real workhorse. So I can't say enough about them. That's why a lot of these companies went out of business. The machines never broke down. So that's it. Going to come off camera there now. I hope that's useful to somebody, just to show that these machines, they're very fixable, just with the right approach and angle of attack. So over and out for now. Chin well. Okay. I'm tired of being on my knees.